start the lecture. Okay friends, good morning. We start the today's lecture. Deepak, Vijay,
Yes,
Aniket,
sir.
can we start the lecture?
Yes, sir.
Okay. Then I'm going to share the screen. His screen is visible, friends.
Yes, sir.
Yes, sir.
Then I want to present the PPT. Okay, we are came here at this point we came in last lecture. Okay, CMRR. Is it correct, friends? Then we are going toward the next point, 4.5, that is the symbol of OpAmp. OpAmp means the operational amplifier. That will be shortly called as an OpAmp. Okay. In a schematic diagram, this is the schematic diagram of the symbol of the operational amplifier. And in schematic diagram, we shows that there is the triangle is shown. That will be triangle is the operational amplifier. And for that triangle there are the five different terminals. Some are the input terminals, some are the biasing sources, and one is the output terminal. These are the input terminals. One is the inverting input and other is the non-inverting input. Inverting is shown by the negative sign, non-inverting is shown by the positive sign. The two are the biasing sources. One is the VCC, is positive VCC, and minus VEE, that is minus VCC or minus VEE, emitter to emitter voltage, and collector to collector voltage, that is VCC, emitter to emitter voltage, that is VEE, and Vout is the output terminal. See, there are the five terminals here, five terminals. These are the two input terminal, this is the one output terminal, and these two terminal are the biasing terminal. These two terminal are biasing terminal. See here, what is the relation between why the input to this terminal is known as an inverting? Because that is the input voltage at inverting terminal and output are out of phase. There will be out of phase. It means that the phase will be inverted. That is the input terminal voltage and output terminal voltage are appears 180 out of phase. 180 out of phase means if here input is in positive half cycle, friends, if here input is in positive half cycle, this is positive half cycle, then here the output should be in negative half cycle, that is negative half cycle. It means that there will be the phase inverts will be appeared in between the voltage at the input terminal and output terminal, hence it will be known as an inverting terminal. Then non-inverting, that is if there is the positive half cycle, the output will be in positive half cycle, output will be in positive half cycle. It means the phase inversion will not be seen in these two terminal. If we compare the output between these two terminal, that is the phase shift or the phase inversion is not appeared. See here, friend, this is the inverting, that is the phase in this terminal, and this terminal will be inverts 180 out of phase, and this will be non-inverting because the phase will not inverts, hence it will be known as a non-inverting. Consider this is the biasing terminal and this is the biasing terminal. We know that there are the two biasing terminal VCC that will be connected to positive VCC, and another is minus VEE. This is not VCC, but it is VEE, and minus VEE is the voltage between two emitters. Okay, such five terminals are here. See that here an operational amplifier is basically the high gain direct coupled amplifier. We know that, and it has two inputs and one output and two biasing sources. But generally, it is operated in single-ended input and single-ended output. Generally, काय केलं जातं? Either non-inverting input ग्राउंड केला जातो किंवा इन्व्हर्टिंग इनपुट ग्राउंड केला जातो. पैकी या दोन इनपुट पैकी एकच इनपुट ठेवलं जातं, एकच आउटपुट ठेवलं जातं. आपल्याला प्रकार माहिती आहेत त्याचे. चार प्रकार आहेत. सिंगल एंडेड म्हणजे डबल एंडेड इनपुट, डबल एंडेड आउटपुट, डबल एंडेड इनपुट, सिंगल एंडेड आउटपुट, सिंगल एंडेड इनपुट, डबल एंडेड आउटपुट, सिंगल एंडेड इनपुट, सिंगल एंडेड आउटपुट. या सगळ्या प्रकारामध्ये जास्त वापरला जाणारा प्रकार जो आहे that is the kind of operational amplifier which will be highly used, it will be highly implemented. That kind will be known as an single ended input, single ended output. In single ended input, the input is the single ended, means that input is single ended, means that either non-inverting or the inverting input is present and only one output is present. That is, output is taken across the one of the amplifier, one of the transistor, and ground. That will be known as a single-ended input and single-ended output. Such, but generally it is operated in a single-ended input and single-ended output, and the differential amplifier forms the first stage of operational amplifier. We know that the differential amplifier is the first stage, input stage of the operational amplifier. Means that is the differential amplifier is the first stage of the operational amplifier. The pin connection, we know that there is the pin connection, and that pin connection is here. ओके, आता पिन कनेक्शन्स मध्ये काय करायला लागतं बघा मित्रांनो. आपल्याला इन पिन कनेक्शन इथं मी लेझर घेतो म्हणजे लक्षात येईल, आपल्याला दिसेल लेझर. हा लेझर आहे बघा, that is pin connection. And in pin connection, the input and output voltages are with the respect to the ground. मगाशी सांगितल्याप्रमाणे इन्व्हर्टिंग आहे. इथं पिन कनेक्शन ऑफ द IC 741, that is IC 7441 741 हा ऑपरेशनल एम्प्लिफायरचा नंबर आहे. आणि IC 741 is widely used operational amplifier. In this IC, when input is 0, output can be adjusted to the 0 varying by varying 10 kilo ohm आहे. Potentiometer is the offset null आहे. फ्रेंड, हिअर ऑफसेट नल आहेत एकमेकासमोरचे 1 आणि 5 ऑफसेट नल आहेत. आणि ऑफसेट नल हा कशासाठी यूज केला जातो? कॅलिब्रेशन साठी यूज केला जातो. कॅलिब्रेशन कुणाचं केलं जातं? ऑपरेशनल एम्प्लिफायरचं कॅलिब्रेशन केलं जातं. कॅलिब्रेशन करताना काय करायचं? त्याला इनपुट समान द्यायचा किंवा इनपुटच द्यायचा नाही. इनपुट दिला नाही तर तो समान आहे, किंवा दिला तर तो समान द्यायचा. आणि इनपुट समान दिल्यानंतर आउटपुट व्होल्टेज आपल्याला 0 मिळायला पाहिजे. आपल्याला माहिती आहे दोन्ही कलेक्टरच्या अक्रॉस आपण व्होल्टेज घेतो. दोन कलेक्टर मध्ये जर सेम मॅग्निट्यूड झाला असेल व्होल्टेजचं, output of the output of the amplifier will be appear in collector. And if both the collector, that is both the transistor in the differential amplifier or operational amplifier are the identical transistor or the equivalent transistor, then then the output voltages which was appeared in collector are the same, but they are directed opposite. That is, the magnitude of the collector voltages are same in the collectors of the transistor Q1 and Q2, or T1 or T1 and T2, but their direction is opposite. त्यांची डायरेक्शन अपोजिट आहे, त्यांची मॅग्निट्यूड समान आहे, डायरेक्शन अपोजिट आहे. आणि असं जर असेल मित्रांनो, तर आपल्याला व्होल्टेज काय मिळेल सांगा? दॅट इज द व्होल्टेज अक्रॉस दी both collectors of the both the transistor is the same, and it will be zero. And if it will be appeared zero, then that will be known as an that is whole operational amplifier or the differential amplifier is to be appear to be calibrated, because it can give the null output. It can give the null output or zero output, and that will be the, if it is not zero, there is some deflection or the some differentiation between two transistor is appeared, then both the, that is the collector voltage in both the transistor is not same, and there is some difference, that is the magnitude of the collector voltage appeared in both the transistor T1 and T2 are slightly different, and we get the sum of the voltage across the collectors of the both the transistor. And there is the one of the screw pot, there is the one of the screw or the one of the pot, and our, with using the screwdriver, just we adjust the screw such that there is the potentiometer, there is the one of the varying potentiometer of the 10 kilo ohm, and its value will be slightly increased. The rotate the screw in such a way, left or right, in such a way that is the output voltage becomes zero, and that will be known as an null adjuster, offset null adjuster. And pin number 1 and pin number 5 are the offset null adjuster. There is the one of the notch जिथं असेल तिथं 1 सुरू करायचं, खालून वरती यायचंय आपल्याला. आपल्याला माहित आहे अँटी क्लॉकवाईज जायचंय. 1 ला सुरुवात होईल, 2 3 4 5 6 7 8 असा पिनचा नंबर आहे. मित्रांनो, पिनचा नंबर तिथे लिहिलेला नसतो. नॉच ज्या बाजूला असेल तो बाजू डाव्या हातात धरायची, नॉच ज्या बाजूला आहे ती बाजू मी डाव्या हातात धरली. बघा मित्रांनो, डाव्या हातात धरली. आता खाली या, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. आपल्याला 8 पिनचं नेमेनक्लेचर करता येईल, आणि नेमेनक्लेचर केलं की आपल्याला काय दिसेल सांगा? त्या 8च्या 8 पिन आपण कशासाठी यूज करतोय? इथं आयसी साठी यूज करतोय. प्रत्येकाचं नाव आहे मित्रांनो. पहिल्याचं आहे ते ऑफसेट नल, दुसऱ्याचं आहे ते इन्व्हर्टिंग अँप्लिफायर किंवा इन्व्हर्टिंग इनपुट. इन्व्हर्टिंग इनपुट म्हणजे हे आणि आउटपुट मध्ये फेज रिलेशनशिप 180 डिग्रीच आहे. नॉन इन्व्हर्टिंग इनपुट फेज रिलेशनशिप 0 आहे, म्हणजे सेम फेज मध्ये आहे. दॅट इज 4 बायसिंग सोर्सेस प्लस VCC, 5 ऑफसेट नल, पुन्हा 6 दॅट इज द प्लस VCC, पुन्हा 7 ट्रिगर व्होल्टेज, आणि 8 इज द नो कनेक्शन. 8 पिनला कसल्याही प्रकारचं कनेक्शन नाही, आणि अशा प्रकारचं पिन कनेक्शन असणारा आयसी हा कोणाचा आहे मित्रांनो सांगा? IC 741 आहे. 741 हा आयसी आहे. त्याच्यामध्ये 8 पिन असतात, त्यातल्या 2 आहे ते नल ऍडजस्टर, 1 पिन आहे ती नो कनेक्शन, आणि उरलेले जे आहेत मित्रांनो 3 आणि 2 5 कनेक्शन होतात. बघा, 2 इनपुट, 2 बायसिंग सोर्सेस आणि 1 आउटपुट. 2 इनपुट, बायसिंग सोर्सेस आणि 1 आउटपुट, अशा 5 पिन आहेत. पण आयसी मात्र आपण इथे किती पिनचा यूज केलेला आहे? 8 पिनचा यूज केलेला आहे. आता तिथून पुढे चाललोय आपण नेक्स्ट पॉइंटला चाललोय, आणि नेक्स्ट पॉइंट इज फ्रेंड that is block diagram of the operational amplifier. बऱ्याचदा हा प्रश्न 10 मार्काला विचारला जातो. That is draw the symbol of operational amplifier, show the pin connection of operational amplifier, and explain each block of operational amplifier in brief. असा प्रश्न 10 मार्काला विचारला जातो. बऱ्याचशाच क्वेश्चन पेपर जर बघितले आपण, तर त्याच्यामध्ये तुम्हाला 10 मार्काचा प्रश्न दिसेल. एकदम सोपं आहे. एक म्हणजे काय करायचंय सांगा? सिम्बॉल ड्रॉ करायचा, एक्सप्लेन करायचा, पुन्हा पिन कनेक्शन ड्रॉ करायचं, एक्सप्लेन करायचं, ब्लॉक डायग्राम ड्रॉ करायची, आणि प्रत्येक ब्लॉक एक्सप्लेन करायचा. देन ब्लॉक डायग्राम ऑफ द CRO. या ब्लॉक डायग्राम मध्ये आलो तर ऑपरेशनल एम्प्लीफायर कन्सिस्ट ऑफ द 3 स्टेजेस. या ब्लॉक डायग्राम मध्ये 3 भाग केलेले आहेत मित्रांनो. एक म्हणजे पहिला भाग आहे फर्स्ट स्टेज कॉल्ड एज अन इनपुट स्टेज अँड विच इज कन्सिस्ट ऑफ द डिफरन्शियल एम्प्लिफायर विथ द कॉन्स्टंट करंट सोर्स. म्हणजे मी इथं जर पेन घेतला मित्रांनो तर लक्षात येईल तुमच्या, हा एवढा जो ब्लॉक आहे ती फर्स्ट स्टेज आहे, ही एवढी जी आहे ती फर्स्ट स्टेज आहे, ही फर्स्ट स्टेज आहे. दॅट विल बी नोन एज अन फर्स्ट स्टेज. याला काय म्हटलं मी, पहिली स्टेज असं म्हटलं. दुसरी स्टेज काय आहे बघा मित्रांनो, दॅट इज ही जी आहे ही दुसरी स्टेज आहे, ही सेकंड स्टेज आहे. आणि ही जी आहे उरलेली ही थर्ड स्टेज आहे. दॅट इज द थर्ड स्टेज इज द आउटपुट स्टेज. ओके. फर्स्ट स्टेज मध्ये, फर्स्ट स्टेज कॉल्ड एज द इनपुट स्टेज. इनपुट स्टेज मध्ये काय आहे बघा, इट कन्सिस्ट ऑफ फर्स्ट डिफरन्शियल एम्प्लिफायर, दोन डिफरन्शियल एम्प्लिफायर आहेत ऑपरेशनल एम्प्लिफायर मध्ये, दोन डिफरन्शियल एम्प्लिफायर आहेत. फर्स्ट डिफरन्शियल एम्प्लिफायर, फर्स्ट स्टेज मध्ये काय काय आहे, फर्स्ट डिफरन्शियल एम्प्लिफायर अँड और विथ कॉन्स्टंट करंट सोर्स, कॉन्स्टंट करंट सोर्स आणि फर्स्ट डिफरन्शियल एम्प्लिफायर ही फर्स्ट स्टेज आहे. सेकंड स्टेज मध्ये काय काय येते बघा, ज्याला मिडल स्टेज म्हटलं जातं. मिडल स्टेज बऱ्याचदा फर्स्ट स्टेजला इनिशियल स्टेज म्हटलं जातं, सेकंड स्टेजला मीडियल स्टेज म्हटलं जातं, थर्ड स्टेजला लास्ट स्टेज म्हटलं जातं. बऱ्याचदा फर्स्ट स्टेजला फर्स्ट म्हटलं जातं, सेकंड स्टेजला मिडल स्टेजला सेकंड स्टेज म्हटलं जातं आणि थर्ड स्टेजला थर्ड स्टेज म्हटलं जातं. नावं काही घ्या, फरक नाहीये. पहिली स्टेज आहे इनपुट स्टेज, सेकंड स्टेज आहे मिडल स्टेज आणि थर्ड स्टेज आहे आउटपुट स्टेज. मिडल स्टेज मध्ये कोण कोण येतंय बघा, दॅट इज द सेकंड डिफरन्शियल एम्प्लिफायर with called as an intermediate stage which consists of, that is the second differential amplifier, emitter follower circuit that is amplifier आणि DC level shifter. DC level shifter आहे, लेवल कमी असली तर वाढवणं, जास्त असेल तर कमी करणं, लेवल शिफ्ट करणं, हे लेवल शिफ्टरचं काम आहे. लेवल शिफ्टर इथं जर इंटरमिडिएट स्टेज मध्ये बघितलं तर 3 ब्लॉक आहेत वेगवेगळे. एक म्हणजे सेकंड डिफरन्शियल एम्प्लिफायर, दूसरी म्हणजे emitter follower circuit, that is the amplifier, that is the emitter follower circuit can be used as an amplifier, and second is the third is the DC level shifter. Level shifter can shift the output at the up or down, and last stage that will be known as a final stage, and final stage is the output stage, and output stage is shown here with the output material. Output stage is shown here with output material. That's why output stage is very essential in this case. Okay. It means that operation in block diagram of operational amplifier, there are the three important stages. One is the initial stage or the first stage, second is the middle stage or intermediate stage, and third stage is the final stage or the third stage. See here, first stage, input stage, in which consists of the first differential amplifier with the constant current source. Second stage is the intermediate stage, that is the second differential amplifier, emitter follower circuit, and DC level shifter. And third stage is the output stage or the output part. This is the diagram. We are going to next, we are shifting to the next output. See here. That is the explanation of the each block. Input stage, second stage, and third stage. These are the three stages here. This is the input stage. What is the function of the input stage? See here. This is the input stage. This is the second stage. And this is the third stage. This is the explanation of the three stages. That is, operational amplifier has the two input terminal. One is the non-inverting and other is the inverting. One output terminal, that is the differential amplifier. The basic building block is the OpAmp. Basic building block कोण आहे मित्रांनो? OpAmp आहे. And the output of this stage is double-ended input, double-ended output. Double-ended input, double-ended output, and output stage is ended. That is the taken two collectors, that is the provider high CMRR, that is common mode rejection ratio, and high input impedance. फ्रेंड्स इथं जर बघितलं आपण काय आहे बघा बारकाईनं, इथं दोन इनपुट स्टेजेस आहे. एक म्हणजे डबल एंडेड इनपुट आहे आणि डबल एंडेड आउटपुट आहे. म्हणजे पहिला जो प्रकार आहे, फर्स्ट स्टेज मध्ये डबल एंडेड इनपुट डबल एंडेड आउटपुट हा डिफरन्शियल एम्प्लीफायर घेतलेला आहे आणि कॉन्स्टंट करंट सोर्स त्याला जोडलेला आहे. कॉन्स्टंट करंट सोर्स काय करतोय, कॉन्स्टंट इनपुट दिला जातोय आणि तो कॉन्स्टंट इनपुट कॉन्स्टंट करंट सोर्सचा या डिफरन्शियल एम्प्लीफायरला, फर्स्ट डिफरन्शियल एम्प्लीफायरला दिला जातो आणि याचा आउटपुट हा सेकंड स्टेजला किंवा इंटरमिडिएट स्टेजला दिला जातो. म्हणजे हा सिम्पली कोण आहे म्हटलं मी, हा सिम्पली डबल एंडेड इनपुट डबल एंडेड आउटपुट हा डिफरन्शियल एम्प्लीफायर आहे आणि ज्याचा इम्पेडन्स हा मोठा असतो, ज्याचा इन्फिडन्स हाय असतो, ज्याचा CMRR दॅट इज कॉमन मोड रिजेक्शन रेशो हा त्याचा काय असतो, हाय असतो. अशा पद्धतीचा जो डिफरन्शियल एम्प्लीफायर आहे that will be known as a basic differential amplifier. It is the first state, it is the initial state of the differential amplifier. It is initial state of a differential amplifier, and the constant current source is with it, means the output of the constant current source is given to the differential amplifier. Differential amplifier ला दिलेलं आहे. म्हणजे इथं काय आहे बघा, इथं आपण CMRR जास्त असणारा, इनपुट इम्पेडन्स जास्त असणारा, डबल एंडेड इनपुट अँड डबल एंडेड आउटपुट असा असणारा ऑपरेशनल एम्प्लीफायर, दॅट इज द बेसिक operational amplifier which is operated according to constant current source. It is connected in this block diagram and it is the input part. It is the input part of the differential amplifier. Input part of differential amplifier. This reduces the noise of the output and help to reduce the drift. Drift माहित आहे, इनपुट व्होल्टेज वाढलं की व्होल्टेज वाढतं, अशा ड्रिफ्ट मध्ये आपल्याला ऍप्लिकेशन करायचं नाहीये आणि that person is going to give, that is the first stage is going to give the output to the second stage. What is the second stage? See here, the second stage, the second stage consists of, just I am taking the laser. The second stage consists of the second differential amplifier, emitter follower circuit. त्याच्यामध्ये emitter follower circuit आहे, पुन्हा differential amplifier आहे, second differential amplifier आहे, emitter follower circuit आहे and DC level shifter आहे. तुम्हाला माहित आहे या स्टेजचा उपयोग काय आहे, तर CMRR इन्क्रीज करणं. कॉमन मोड रिजेक्शन रेशो जो आहे, म्हणजे गेन जे आहे ते आपल्याला वाढायला पाहिजे आणि ते वाढवायचं काम या मिडल स्टेजचा, इंटरमिडिएट स्टेजचा आहे. आणि इंटरमिडिएट स्टेज मध्ये त्यासाठी काय घेतलेलं आहे, डबल एंडेड इनपुट सिंगल एंडेड आउटपुट डिफरन्शियल एम्प्लीफायर घेतलेला आहे. दॅट इज द सेकंड स्टेज. सेकंड इज द इमिटर फॉलोअर सर्किट. इमिटर फॉलोअर सर्किट इज द amplifier. And third one is the DC level shifter. DC level shifter आहे. The emitter follower circuit is the very high impedance and low output impedance. म्हणजे काय आहे बघा, हा इमिटर फॉलोअर सर्किट आहे, म्हणजे एम्प्लीफायर आहे आणि तो एम्प्लीफायर काय करतो, त्याचं जे हाय इनपुट इम्पेडन्स आहे आणि लो आउटपुट इम्पेडन्स आहे, ही कॅरेक्टरिस्टिक इथे यूज केली जाते. म्हणजे जी सेकंड स्टेज आहे, सेकंड स्टेज ऑफ डिफरन्शियल एम्प्लीफायर आहे, त्याचा प्रकार बदललेला आहे. डबल एंडेड इनपुट सिंगल एंडेड आउटपुट आहे आणि त्याचबरोबर त्याचा आउटपुट आपण दिलाय कशाला मित्रांनो, त्याचा आउटपुट आहे, त्याचा आउटपुट दिलेला आहे. फ्रेंड्स, after 10 minutes, the meeting will be end. Again we on same link, again you click and join again, because today there is the limit of the 40 minutes. After ending the meeting, there is humble request from my, that is you will click the link again and join again for the meeting after 10 minutes after ending the meeting. Okay, see here, that is the stage, and that stage is known as a second stage, in which the one of the basic differential amplifier of a kind, double ended input and single ended output, and its output is connected to emitter follower circuit. Emitter follower circuit here acts as an amplifier, and amplifier is the common emitter transistor amplifier mode, is used in case of the emitter follower circuit. And the third stage is the level shifter, that is here. The next stage acts as the buffer between the two stages. बफर आहे, जर कमी असेल तर वाढवायला लागेल, जास्त असेल तर कमी करावं लागेल. टू अवॉइड द ओव्हरलोडिंग कमी करण्यासाठी आपण बफर यूज करतोय. द नेक्स्ट स्टेज इज द डीसी लेवल शिफ्टर, and in DC amplifier the DC level shifter is cascaded stage which increases due to the direct coupling, and finally it is the equal to the power supply voltage. In absence of the input, the output may not be zero, and therefore the DC level shifter is used here. Friends, here what is the application of the level shifter? Why the level shifter is used? Because we know that in emitter follower circuit we are going to avoid the overload, and after avoiding the overload, there is the cascade arrangement of the DC level shifter, and due to this the direct coupling, the resistance of that coupling will be came, and due to that resistance either output will be increases or decreases, means that the null detector output should be null output have to come the zero. But in different cases due to the overload of the cascade application of the direct coupling, the output will be increases, means it is positive, or decreases, it means it is negative, means that it is greater than 0 or it is less than 0. We know that for the calibration of the differential amplifier there is the requirement of calibration, means that we have to set the output to 0. We have to detect first the output should be null or not. If it is not null, means either it is positive or either it is negative, either it is greater than positive or either it is less than 0, then the role of DC shifter is came. And as the name given, it shifts the DC output. It is level shifter, and level shifter can make lever up and down. And here the level shifter is used to make or used to calibrate the output of the differential amplifier or operational amplifier. When we use the null detector or the null shifter key pot to calibrate the output of the operational amplifier, it regulates the DC level shifter, and the role of the DC level shifter will be came in active at this stage, and level shifter can shift the output of the operational amplifier on either up direction or either in down direction. And by moving the pot by screwdriver easily, there is the mechanical treatment. There is no electronic treatment. Simple mechanical treatment is used by inserting the screwdriver in the screw of the null detector. We can shift the level shifter up and down and calibrate the operational amplifier. We can able to calibrate the operational amplifier. And here in calibration of the operational amplifier, the role of intermediate stage, actual role of DC level shifter is very important. And here the DC level shifter is came in force to calibrate the output of operational amplifier to 0. Means the calibration can be done with using the level shifter only. But in intermediate stage, there are the three different parts. That is the second differential amplifier with the type of double-ended input and single-ended output. Second is the emitter follower circuit, because the output of the operational amplifier we have to increase it. We have to increase its input impedance also. We have to increase its CMRR also, that is the common mode rejection ratio, and for that amplification is necessary, and for amplification the type of emitter follower amplifier is used. And third one is the level shifter, and level shifter is very essential to shift the output either in both up and down direction. And for here, with using level shifter, we can calibrate the output of the operational amplifier. Understand it? मित्रांनो हे लक्षात ठेवा नेमकं इंटरमिडिएट स्टेजचं काय काम आहे. आता आपण स्विच होतोय दॅट इज द लास्ट स्टेज और द थर्ड स्टेज ऑफ द ऑपरेशनल एम्प्लीफायर. द लास्ट स्टेज ऑफ द operational amplifier is the output stage. Simply it will be known as an output stage or the third stage. काही नाव घ्या, थर्ड स्टेज म्हणा, फर्स्ट सेकंड थर्ड, किंवा दॅट इज द इनिशियल म्हणा, इंटरमिडिएट म्हणा आणि लास्ट म्हणा, किंवा इनपुट स्टेज म्हणा, इंटरमिडिएट स्टेज म्हणा आणि आउटपुट स्टेज म्हणा. नाव काही द्या, त्याचं फंक्शन मात्र सेम आहे. The last stage is the output stage. Output stage is the push-pull power amplifier. Push-pull, push, that is ढकलणे, pull ओढणे. इथं ढकलणे आणि ओढणे, that is it is in accordance with the level shifter, and level shifter can shift up and down, that is the pushing up and pulling down, pushing up and pulling down. And such application will be known as an push pull power amplifier. Means that the output stage will be worked like the power amplifier, like the switch of the push and pull, like that application will be operating here. And the output impedance of this stage is very low. We know that in case of operational amplifier, that is the output stage, the low output impedance will be seen, and it will be provide the sufficient current to the load without a distortion. And so here large output voltage without distortion is to be obtained. That is the last application of the operational amplifier will become in active. Here, that is we get the last application. That is what we want. We want there is the large output without distortion, and that will be applicable, that will be given only at the output because of the push pull power amplifier function. And if we use the power amplifier function, the output should be become the high as well as without distortion. It will be constant, because we know that in input stage, the constant current source is used, and due to the constant current source which was used in input stage or the initial stage, the output should be become very high, and it will be appeared undistorted, that is the distortion will be very less, it is nearer to zero, where will be less distort output will be appeared at the output. And this is the third stage of the operational amplifier. Friends, here we completed the working according to block diagram of the operational amplifier, in which just I am taking the review because the time will be remaining very less. That is just we have to join again after the closing this meeting, after ending this meeting. We know that there are the three stage: input stage, intermediate stage and output stage, or the first stage, second stage or third stage, or the input stage, that is the second is the operating stage or intermediate stage, and third is the output stage. Okay, in input stage, what is the function of the input stage? That is, there is the constant current source with respect to double-ended input, and तेजश्री व्हॉट्सअपला मेसेज द्या. तेजश्री.
Yes, sir.
ओके, परत एकदा मेसेज द्या. जॉईन फास्ट अगेन. Give submit an attendance in chat box. Please submit your attendance in chat box. Okay, friends. Again, I am going to share the screen. Okay, I am going to share the screen again. Friends, screen is visible.
Yes, sir. Yes.
Okay. Then OpAmp parameters. Here is the OpAmp parameters. Then there are the different parameters, that is different constant for the OpAmp operational amplifier. That is input bias. The important parameters of the operational amplifier will be discussed as follows. The input bias current, that is the input bias current असं म्हटलेलं आहे. What is the input bias current of the operational amplifier? Since the input terminal of the bipolar differential amplifier, since the input terminal of the bipolar differential amplifier are the transistor basis, so the input currents are the base current. We know that. Just the construction details of the designing details of the operational amplifier. There are the two transistor Q1 and Q2, which are the Darlington pair of each other, and at the basis of the two transistor, we are submitting the voltages V1 and V2. Okay, and after submitting the voltage V1 and V2, the base currents IB1 or IB2, or it may be I1 and I2, will be flowing with through the base, and that base current will be amplified at the collector, because that is the which mode of the amplifier, that is the common emitter mode of the amplifier, that is the base current which is flowing through the emitter, it will be amplified at the collector, and that will be known as an beta is equal to, that is the IC divided by IB, and it will be about the 50 to 500 in case of the common emitter mode transistor amplifier, that will be more known as an current gain. Okay, uh, here here in case of the operational amplifier, we are using the base supply, and basis of the two transistor are given, or submit the voltages V1 and V2. It may be known as a non-inverting voltage or inverting voltage, and due to that, the base currents starts flowing. And here in this diagram, the base currents are shown by the letters I1 and I2. Consider that this is the diagram. Okay, the V1 is the non-inverting voltage, V2 is the inverting voltage, sorry, against that, V1 हे इन्व्हर्टिंग व्होल्टेज आहे कारण निगेटिव्ह दाखवलेलं आहे. V2 इज द पॉझिटिव्ह आहे म्हणजे नॉन इन्व्हर्टिंग व्होल्टेज आहे. I1 आणि I2 त्याच्यामधून बेसमधून होणारे बेस करंट्स फ्लो होत आहेत. आणि आउटपुट जर बघितलं आपण, व्हॉट अबाउट द आउटपुट? द आउटपुट that is the output is, what is the output? It is the, it can amplification factor, that it can amplify the difference between inputs, and so it will be known as an differential amplifier, or in this case it will be known as an operational amplifier. Okay, then what about the bias current, input bias current? And input bias current is the average of the base currents. And what is the average? That is the I1 plus I2 divided by 2 is the input bias current. And here input bias, IBIOS, IB, that is the base current of the bias, and base current of the bias is the average of the two base current, I1 plus I2 divided by 2. The input bias current is the DC current required, the input of the amplifier to properly operate in first stage. हे कशासाठी आहे मित्रांनो? We have according to input bias current, there is the proper working, proper work of the first stage of the differential amplifier, first stage of operational amplifier has to become. And for the proper working of the first stage, input bias current is very essential. And input bias current is calculated from taking average of the both base currents, that is I1 plus I2 divided by 2 is the average, and that average is known as an input bias current. And input bias current is very necessary for the proper operation of the input stage. And we know that input stage is the differential amplifier, and which type of the differential amplifier is the double-ended input and double-ended output. And for that we have to take the input bias current. And typically in case of generally for the operational amplifier, the input bias current is very less, and it is about the 80 nano ampere. It will be NA. ही फिगर कुठेतरी लक्षात ठेवा मित्रांनो, ही कशासाठी विचारली जाईल. What is the input bias current of the operational amplifier? And it is the 80 nano ampere. जनरली तो किती असतो? 80 नॅनो एम्पियर असतो. नॅनो एम्पियर आहे, एन कॅपिटल ए आहे मित्रांनो, एन फॉर नॅनो, ए फॉर एम्प्लिफायर, नॉट एमईए, मिली एम्पियर नव्हे, किंवा दुसरं काही नोटेशन नाही आहे, एनए नोटेशन आहे. आणि एनए मे बी दी, just wait, battery is draining here. Okay, ha, CF, that is IB is equal to 80 nano ampere. Second is the input offset current. What about the input offset current? Ideally the two input base currents are equal. जवळ ते इक्वल असतात का सांगा? आपण डार्लिंग्टन पेयर, आयडेंटिकल ट्रान्झिस्टर, इक्विव्हॅलंट ट्रान्झिस्टर आपण यूज करतोय. त्यामुळे इथं बाहेर जर इक्वल व्होल्टेज दिलं तर इक्विव्हॅलंट बेस करंट फ्लो होणार. त्यामुळे I1 आणि I2 नियरली इक्वल असणार किंवा इक्वल असणार. आता इथं ideally the two input base current are equal, and thus the difference is the zero. And in practically, हे झालं theoretically ते असायला हवं झिरो, पण प्रॅक्टिकली असतं का? नो, देर इज सम difference, and we get some output voltage, and we have to calibrate it. And calibration in case of operational amplifier is very important. माहित आहे आपल्याला, आपण काय करतो पेट्रोल पंपावर पेट्रोल भरताना आपण काय म्हटलं जातं, व्हॉट इज द, तिथं काय सजेशन असतं, इन्श्युअर बिफोर, म्हणजे इन्श्युअर दॅट इज द रिडिंग इज झिरो बिफोर फिलिंग. आपण खात्री करा अगोदर, तेल भरण्या अगोदर रिडिंग झिरो आहे की नाही. तसं ऑपरेशनल एम्प्लिफायर जर मला यूज करायचं असेल तर आपल्याला माहिती आहे ऑपरेशनल एम्प्लिफायर कशासाठी यूज करणार आहे. we have to use to operate for the different mathematical operation. In mathematical operations such as the addition, subtraction, multiplication, division, derivative, again integration, exponential, other than the number of mathematical operation. And for that performing that operations we use the operational amplifier. And before using we have to calibrate it, And if it is not calibrated, the answers will be wrong. 2 plus 2, it is the 4. If it is not calibrated, it gives the 4.25. Means that the calibration error will become, and hence we have to calibrate it. And to calibrate, we have to set the input offset voltage. It have to say we have to set the input offset current, not voltage. We have to set the input offset voltage. And practically the operational amplifier, however, the base current are not exactly zero, or the difference is not exactly zero, means the both the base current are not exactly equal असतील तर त्यांचा डिफरन्स झिरो येईल, जर इक्वल नसतील तर डिफरन्स झिरो येणार नाही. And hence however the base current are not exactly equal, and the input offset current IOS is the difference in the two input. But we know that input offset current IOS is equal to mod of I1 minus I2, आणि आपल्याला माहित आहे हा जवळजवळ 25% येतो, लेस दॅन 25% येतो, आणि हा जवळजवळ 20 नॅनो अँपिअर येतो, आणि हा आपल्याला झिरो करावा लागेल. वी हॅव टू डू इट इज झिरो. आणि हा झिरो करण्यासाठी जे व्होल्टेज देतो एक्स्ट्रा व्होल्टेज, तो झिरो करायसाठी इन्श्युअर टू झिरो, तो झिरो आहे की नाही ते खात्री करण्यासाठी आपण जे व्होल्टेज देतो त्याला म्हणायचं इनपुट ऑफसेट व्होल्टेज. आणि इथं दिलंय बघा, या दोन डायग्राम मध्ये आपण इनपुट ऑफसेट व्होल्टेज दिलेले आहेत. नंबर 3च्या डायग्राम मध्ये, that is input offset voltage, and input offset voltage is VIO, and when the input of the operational amplifier are grounded, the output must be zero. But there is the small error voltage at the input due to the difference in the VB value, of the input transistor, and this is called as the input offset voltage. That is the this is called as the input offset voltage. We have to give the input offset voltage to give the output offset voltage zero. Input offset voltage कशासाठी द्यायचा? To get the output offset voltage, means the Vout should be zero. That is, there are the some the deviation from the deviation will be observed between the two base currents. There is some deviation practically. There is some deviation will be observed between two base current. We have to apply some extra voltage at the input terminal, any one of the input terminal. Take any one of the input terminal, that is the inverting input or the non-inverting input, but usually use the inverting input. कुठल्याही टर्मिनलला देता येतंय, पण इंटरनॅशनल कोड आहे, सगळ्यांनी एकसारखंच आपल्याला ऑपरेट करायचं आहे. इंटरनॅशनल स्टँडर्ड कोड आहे मित्रांनो. जनरली इन्व्हर्टिंग जी टर्मिनल आहे, इन्व्हर्टिंग टर्मिनलला पॉझिटिव्ह किंवा निगेटिव्ह बॅटरी जोडायची, आणि आपण इनपुट ऑफसेट व्होल्टेज हे इक्वल करायचं, आणि इनपुट ऑफसेट व्होल्टेज इक्वल करायचं म्हणजे आउटपुट ऑफसेट व्होल्टेज झिरो करायचं. मग इथं जर बारकाईनं बघितलं तर इनपुट ऑफसेट व्होल्टेज जे आहे ते VIO असं म्हटलेलं आहे, आणि इथे एक बॅटरी VIO एका इन्व्हर्टिंग टर्मिनलला दिलेली आहे, आणि ह्या बॅटरीची किंमत असते, ह्या बॅटरीचं व्होल्टेज असते प्लस मायनस 2 मिलीव्होल्ट. इट इज प्लस मायनस 2 मिलीव्होल्ट. जस्ट व्हेरी नाईस, अगदी बरोबर आहे माझं मित्रांनो. that is the typically input offset voltage is plus minus 2 millivolt. बऱ्याचदा ऑब्जेक्टिव्ह मध्ये प्रश्न विचारला जाईल, व्हॉट इज द इनपुट ऑफसेट व्होल्टेज? जनरल व्हॅल्यू ऑफ द input offset voltage for the operational amplifier or the differential amplifier is, उत्तर काय लिहायला पाहिजे मित्रांनो? that is plus minus 2 millivolt. Why plus minus? We know that in block diagram we are using the level shifter. Level shifter is the push pull power amplifier. What means the pushing? Pushing means increasing. What means the pulling? It will be decreasing. And in number of operational amplifier or the differential amplifier, it requires the push, or in number of operational amplifier it requires the pull. And pushing means supplying plus 2 millivolt. Pulling means we have to pull back, that is we have to supply minus 2 millivolt, and hence plus minus 2 millivolt is the input offset voltage for the differential amplifier as well as the operational amplifier, because operational amplifier is the basically differential amplifier, and in operational amplifier we are going to use the two differential amplifier one in first input stage, that is the double-ended input and double-ended output type, and in second stage there is the double-ended input and single-ended output type differential amplifier. Means that the operational amplifier is the differential amplifier. Generally it is the differential amplifier. That is slew rate. Slew rate, that is the rate of increasing. That is the maximum rate of change. Rate of change. That is the uh, dabba by dabba d by dabba t. That is the rate of change of d with respect to t. Dabba dv by dt. That is rate of change of v with respect to t. That is the change, and we have to take the derivation. And for change, mathematically we can take the derivation. But here in electronics, by mean of electronics, we have to take the derivation. It means we have to take the slew rate. And what is the slew rate? The maximum rate of the change of the output voltage in response of the step input voltage is the slew rate of the operational amplifier. म्हणजे आपण with respect to t, with respect to change in t, with respect to in small moment of the time, what will be the change? What will be the increase in voltage? That will be known as a slew rate. Slew rate म्हणजे काय आहे मित्रांनो? That is the voltage is increasing with respect to time. That is the graph of the voltage versus time चा graph आहे. If we take this very small instant of the time, very small instant of the time, that will be changes the output voltage. And how much voltage will be changed in how much time? If we take the ratio of change in voltage with respect to change in time, that will be give the slew rate. That will be, we can able to calculate the slew rate. And how the slew rate is to be calculated, it will be shown in this diagram. The slew rate is the depend upon the high frequency responses of the amplifier. We know that that is the there will be the change in rate of change of slew rate of the frequency. If the frequency is to be changed, we know that the gain will be depend upon the magnitude of the frequency. In the case of the transistor amplifier, we have to we see the one of the frequency response curve, and in frequency response curve we get the curve of the output voltage with, or the gain of the amplifier with respect to the frequency, and the frequency will be low frequency band, medium frequency band, and higher frequency band. And we see that in medium frequency band the gain is the less, in in low frequency band the gain is the less, in medium frequency band the gain is the constant, and in higher frequency band the gain is the it will be decreases. Means that the increasing mode will be will be found in low frequency, decreasing mode will be found in high frequency band, and at intermediate frequency band means in only the human audible range, in only in the human audible range, that is the gain become constant. And this will be very very useful. Like that here a pulse is applied to the, here pulse is applied to the input, and the ideal output voltage is measured, and that ideal output voltage will be measured, is shown in the diagram B. Friends, here this is the non-inverting input, and for non-inverting input the one of the voltage source is to be used, and that voltage source is known as a V in, and that Vn will be shown here. And also we we have to need to see that what is the slew rate. And here the slew rate is the, that is the graph of the change in voltage with respect to change in time. If we take the change in time is unit, then directly change in voltage gives the gives the slew rate. The width of the input pulse will be very very sufficient. Here width will be delta t घेतलेली आहे मित्रांनो, and with the requirement of the time change in delta t, the voltage change, that is change in voltage, will be observed at the V out, and it will be floated. And if we get the float, if we get the graph of the output voltage versus the time, and output voltage is the change in voltage and time is the change in time, that is the delta, then from minus V max to the plus V max, slew rate is the change in output, and change in output divided by delta V and fair, where the V out is equal to V max minus V max, and here generally the slew rate should be very very less, and that will be the 0.5 volt per microsecond. किती आहे बघा, that is the 0.5 volt per microsecond. म्हणजे इथं आपण जर बघितलं तर एका सेकंदाला किंवा 0.5 व्होल्ट मायक्रोसेकंद हे आपल्याला कशाला मिळतं, दॅट इज एका युनिटला आपल्याला स्लीव रेट मिळतोय. त्यामुळे हा स्लीव रेट सुद्धा आपल्याला वाढवता येतो किंवा कमी करता येतो. इट विल बी अकॉर्डिंग टू द कॉन्स्टंट ऑफ करंट सोर्स which was passed, which was applied near the first stage of the differential amplifier or in the block diagram of the differential amplifier. Okay, then fifth characteristic or the parameter, that is the open loop gain. That is, loop gain is open and closed. There are the two loop gain. Differential mode gain, that is the gain of the differential amplifier without negative feedback. If the negative feedback is called as an open loop, and it is the ratio of the output voltages in the input voltages where there are no external component, where that is the no external component is present, then gain is open gain is equal to V out divided by V in. That is the open gain, that is V out divided by V in is the only gain, and for ideal amplifier the open loop gain is very very high, and it is about the 1 2 3 काय होते बघा, it is about the 10,000. किती आहे बघा, that is the in ideal operational amplifier the open loop gain is the very very high, it is infinite, and in 741 for the zero the open loop gain is about the 10,000. It will be about the 10,000 friend. See here, then 6 is the closed gain, and it is the voltage gain of the operational amplifier with the external feedback not internal nahi hai, and the using it uses the negative feedback घेतलं तर due to the negative feedback the gain is stabilized, and there is the there is the decrease in the distortion. ही जर क्लोज लूप गेन जर वाढली मित्रांनो तर डिस्टॉर्शन कमी होतं, आणि याचा व्हॅल्यू आहे that is the gain of the closed loop is equal to AOL, that is divided by 1 plus AOL minus beta, where AOL is the loop gain battery आहे, that is the AOL म्हणजे loop gain आहे, आणि B म्हणजे feedback fraction आहे, आणि ह्याची व्हॅल्यू मात्र मित्रांनो कमी येते. And for 741 its value is very very less, and it is about the 7, it is the about the 7. The frequency response curve मी सांगितलं मगाशी, frequency response curve shows that the change in voltage gain with the frequency, and gain of the that is the gain without feedback, it is the open loop gain. यातल्या थोड्याशा आपल्याला व्हॅल्यूज पॅरामीटरच्या व्हॅल्यूज आपल्याला लक्षात ठेवावे लागतील, थोडीशी पाटी पेन्सिल घ्यावी लागेल, आणि आपल्याला पाठ सुद्धा करावे लागतील मित्रांनो. पुढे बघा, दॅट इज ओपन लूप गेन इथं अबाउट 10,000 एकम दहम शतम सहस्र दशसहस्र 1 लाख आहे बघा, 1 लाख आहे लाख. पुन्हा फ्रिक्वेन्सी ऍट विच द गेन इज 70.7%, म्हणजे आपल्याला माहित आहे जिथं आपल्याला काय मिळतो, ओपन लूप गेन मिळतो, आणि तो इथं जर बघितला तर 70,700 आहे मित्रांनो, तोही जास्त आहे. पुन्हा जर खाली बघितलं तर क्लोज्ड लूप आहे, क्लोजर लूप कट ऑफ फ्रिक्वेन्सी 1000 हर्ट्ज आहे मित्रांनो, अँड बिहाइंड दिस फ्रिक्वेन्सी द ओपन लूप अँड क्लोज लूप गेन आर कॉमन आहे. आठवा आहे बघा पॅरामीटर इनपुट इम्पेडन्स. इनपुट इम्पेडन्स इज रेशियो ऑफ द इनपुट व्होल्टेज डिवायडेड बाय इनपुट करंट, that is Zin is equal to Vin divided by Zin. Zin is equal to Vin divided by Iin, and thus large value with the input terminal, it will be tied together, and it is about the 100 mega ohm किंवा several the mega ohm अशी आपल्याला व्हॅल्यू घेता येत नाहीये सध्यापर्यंत, आणि तो सध्या घ्यायचा प्रयत्न आहे. म्हणजे we have to change the parameters of the we want to change the parameters of the differential amplifier. आउटपुट इम्पेडन्स मित्रांनो जास्त असतो तो 500 ते म्हणजे 200 असतो किंवा 200 ते 500 असतो असं म्हटलं तर चालेल. पहिल्यांदा त्यांनी जास्तीची व्हॅल्यू लिहिलेली आहे, कमी नंतरची व्हॅल्यू लिहिलेली आहे. दॅट इज द इनपुट इम्पेडन्स अँड बँडविड्थ, power dissipation of the bandwidth, the power dissipation. Okay, here that is the power dissipation. Power dissipation means that the power width and power bandwidth काय दिसते बघा मित्रांनो, power dissipation it will be known as an PD, and this rating is the maximum power dissipation. We know that the power dissipation is the power transfer, and here the power dissipation of the op-amp in a normal abundant temperature, normal temperature ला जी power dissipate होते त्याला power bandwidth असं म्हणलेलं आहे किंवा power dissipation असं म्हटलेलं आहे. आणि टिपिकली फ्रेंड्स ही किती असते, 500 मेगावॅट असते. 500 मेगावॅट ही त्याची व्हॅल्यू आहे. जस्ट टेक इट रिमाइंड किंवा जस्ट fix this figure in your brain, because in some objective question it is to be asked, what is the power dissipation or the power bandwidth of the differential amplifier or the operational amplifier. That is typically the rating is about the 500 megawatt, not megahertz. It is measured in megawatt. Okay friends, we stop here. If anyone has any difficulty, then please ask me. I will try to explain again. Please give your attendance in chat box. Submit your attendance in chat box. मित्रांनो, संख्या अजून कमी आहे, जरासं लक्ष द्या. सगळ्यांना सांगत चला संख्या वाढवा म्हणून. हे लादे सर घेणार आहेत का विचार? फक्त फोन करा. होय काय? नाही घेणार. Friends, please give the attendance in chat box. प्रतीक्षा, विजय, श्रुती, श्वेता, पूनम, दीपक, तेजश्री, प्रज्वल, अमृता, अनिकेत, ऐश्वर्या, प्राजक्ता आणि धनश्री. Please give your attendance. Please submit your attendance in chat box. सबमिट केला का परत?
सर
हा बोला. बोल ना अमृता.
काय नाही सर.
हा सबमिट केला का अटेंडन्स? पूनमने आता केला.
हा सर करते.
हा करा. Please submit the attendance. Please submit your attendance.